I'm back, and now I want to do one more example for you of how to do a pulley problem. And so we're going to, I've hit the reset button, and this time I want to look at this one. And so what I did was instead of making the pulleys side by side, I put the pulleys on top of each other. So here you've got a rope that goes over one pulley, and then it goes underneath another pulley, and then it goes over this pulley, and then it goes under this pulley, and then it goes back to here. Okay, so count the number of ropes holding up the weight. So this time there's going to be 4 of them. I know it doesn't look like it, but if you look here, you got 1, 2, 3, and then 4. So all 4 of these ropes are physically connected to this weight down here. So here you had 2 ropes. Here you've got 4 ropes holding that thing up. So before I give you the answer, can you figure out what should happen? It's a 10 Newton weight. You're lifting it up 0.14 meters. So how much force are you going to need to apply to the rope, and then how much rope are you going to have to pull in order to lift it? Okay, you made your prediction? Okay, so there's 4 ropes holding it up, so we're going to take 10 newtons divided by 4. So that's going to be 2.5. So we should only have to pull 2.5 newtons of force in order to lift this 10 newtons. But what's the bad news? So the bad news is going to be that I'm going to have to pull 4 times the amount of rope. So if we're lifting this thing up 0.14 meters, then I need to take 0.14 meters and then multiply it by 4. Okay, and so what's that going to be? So 4 times 14. So what's that going to be? Okay, so it's going to be 5.6 when you do that. Or, I'm sorry, 0.56. So 0.56. So that's going to be the amount of rope that you're going to need to pull in order to lift this thing 0.14 meters. Okay, so grab the handle here and then start pulling. Nothing happened. Keep pulling. And then all of a sudden it starts to move. Look at how far that rope went. So you see he had to pull a long distance in order to raise the box 0.14 meters, and then you can read the numbers over here and you'll see it turned out to be what we calculated it to be. So that if you take 2.5 newtons, that's your force that you're putting in, and then you multiply it by 0.56 meters, that's going to equal the force out, which was 10 times 0.14. Okay, so now we can get rid of this, and so now let's go back to the notes. We're going to go back to the notes. There we go. Okay, so here is the examples. Now the last example that's on there, that picture there, we did not do that picture. So what we did was for 4 ropes, and in that last picture it's 3 ropes. So, but you should now know how to do a problem like that. So, how much force needs to be applied and how much rope needs to be pulled to lift the 200 Newton box to a height of 3 meters using the following pulley? Okay, so first thing you ought to do is count how many ropes are attached to the weight down here, and you will see that there's 3. So there's 3 ropes. So you've got the one that's here, you got the one that's here, and then there's another one that's there. So you got 3 ropes, and you're going to then take the weight that you're going to lift, so 200 divided by 3, so 1/3 of that's going to be 67 newtons. So that's the good news. You only need to pull with 67 newtons of force in order to lift 200 newtons. But the bad news is going to be you're going to have to pull 3 times the amount of rope. So if you want to lift it 3 meters, you're going to have to pull 9 meters of rope in order to do it. All right, let's take a break. When we come back, we're going to talk about the wheel and the axle.